Hello everyone, welcome to my channel. Now this is the first video on the topic waves, and in this video we are going to understand the various types of waves. We will also understand what is the mathematical equation for a wave, and from that equation how to identify the wavelength, the amplitude, the frequency, the angular frequency associated with a given wave, and also looking into the equation how to say whether the wave is propagating along positive x-axis or negative x-axis. We can identify the direction of propagation of a wave looking into the equation. Okay. Now, before we go into the mathematical details of this topic, let us first understand what is actually a wave. Now, suppose you have some pendulums suspended from a rod like this, and these pendulums are closely spaced. Okay, and suppose this pendulum, it is pulled to this side and then it is left. Then so this pendulum will strike this pendulum, and so this pendulum will be disturbed from its position. It will go in this direction. This pendulum will be disturbed next, and finally this pendulum will be disturbed. Okay, so what I have done, see, I have given some energy to this pendulum. Okay, and this pendulum has transferred that energy to this pendulum, then to the next pendulum, then to the next pendulum. So there is a transfer of energy from this point to this point. Okay, but what about this pendulum? See, this pendulum, it is oscillating like this. This pendulum will oscillate like this. So each and every pendulums, they are oscillating about their positions. Okay, without leaving their positions, they have transferred the energy from one point to another point. Okay, so this is what is wave. Wave is a propagation of disturbance from one point to another point. But there is no transfer of matter. Okay, matter, like in this case the bob of the pendulum, it oscillates about its mean position, and there is a transfer of energy and there is a transfer of momentum. Okay, so this is what is wave. So when you ask to write the definition of wave, you must say that wave is a form of disturbance where there is a transfer of energy and momentum without any transfer of matter. There is no transfer of matter. This is what is a wave represents. Okay. Now next we will understand what are the various types of waves. One classification is based on the way the particle oscillates. Okay. Now suppose you have a string, okay, and the string is fixed at both ends. Suppose these are the two rigid ends, and if this string is plucked like this, so this string, it will vibrate like this. Okay, so in this case the string is vibrating like this and the wave is propagating in this direction. Okay, so this is the direction of wave propagation and this is the direction of the vibration of the particles. So here the particles are vibrating perpendicular to direction of wave propagation. So this kind of wave is called a transverse wave. Okay, so in a transverse wave, the particles of the medium, they vibrate perpendicular to the direction of wave propagation. Okay, now next we will see longitudinal wave. Longitudinal wave. Now see, when I am speaking, I am producing sound energy. Okay, so because of this release of sound energy, these molecules, they will acquire energy. The molecules which are near my mouth, they will acquire energy and they will move in this direction. So they will collide with the molecules at this point. Okay, so there will be an increase in concentration of molecules in this region. So these molecules will collide with these molecules, and these molecules which are at this particular position, after acquiring energy from these molecules, they will move in the forward direction. Okay, and this molecule, after collision with that molecule, it will come like this. So molecules, all the molecules in between me and you, okay, if you are sitting in my class, then there will be molecules will be oscillating in this direction like this, and this is the direction of the wave propagation. So suppose this is the direction of wave propagation, the molecules are oscillating like this. Okay, so here the molecules are oscillating parallel to direction of wave propagation. So this kind of waves are called longitudinal wave. So in longitudinal wave, particles of the medium, they vibrate parallel to direction of wave propagation. Okay, so this is one type of classification of waves based on the way the particles are behaving in the medium. Okay, there is one more classification, that is mechanical wave and non-mechanical wave. Okay, mechanical wave and non-mechanical wave. Now, mechanical waves are those waves which requires a medium for their propagation. Okay, like sound wave. Sound wave can propagate only when there is a presence of medium. Sound waves cannot travel in vacuum. Okay, so if I am taking this class in a space or in moon, then I will not be able to speak like this. I will need to use a radio transmitter and you need to use a radio receiver. Okay, and the other type of wave is the non-mechanical wave. Non-mechanical waves are those waves which do not require a medium for their propagation. Okay, they don't require a material medium for their propagation, like electromagnetic wave, light wave. Light wave is a part of electromagnetic wave. Light from sun, it reaches earth through space. Okay, so it can propagate even in the absence of medium. So non-mechanical waves are those waves which can propagate even in absence of medium. Okay, there is one more type of waves, that is called the matter waves. Matter waves. Now these matter waves are also called de Broglie waves. Now these are the waves associated with the orbital motion or the motion of electrons, protons, neutrons, or the subatomic particles, or even molecules. Okay, so such are called the waves associated with the motion of such particles are called matter waves or de Broglie waves. Okay, so these are the various classification of waves. Okay, now let us proceed to the mathematical form or mathematical equation of the wave. Now suppose let me draw a simple transverse wave. So this is x-axis and this is y-axis. This is y-axis. Okay. Now this is one wave. Okay. Now in terms of wavelength, we know that from this point to this point, the total distance is lambda. This is one wavelength. And in terms of time period, one oscillation gets completed from this point to this point. Okay, so in terms of time period, this is capital T. T is the time period. Okay, so and suppose this is plus A and this is minus A. This is the maximum displacement in the upward direction. This is the maximum displacement in the downward direction. Okay, so as you can see, for this particular point, the coordinate will be, see, x is equal to 0. This is x equal to 0. Then t is also equal to 0 and y is also equal to 0. Okay. Now for this particular point, it is x is equal to, from this point to this point, the distance is lambda. So this is lambda by 2. X is equal to lambda by 2. This total time is t. So this time will be t by 2. So t is equal to t by 2 and y is equal to 0. Okay. Now if you see this particular point, it is x is equal to, so this is lambda by 2, so this is lambda by 4. This is similarly, this is t by 2, so this is t by 4 and y is equal to plus a. Okay. So from this diagram, what is our observation? See, particle, in this case, see, wave is propagating along x-axis and particle is vibrating along y-axis. So the displacement of the particle is along y-axis, the displacement of wave is along x-axis. Now what can we say about the displacement of the particle? As we can see, the displacement of the particle, it depends on the value of acquired by x and the value acquired by t. Okay, so we can say that y is a function of x and t. Okay, y is a function of x and t. Okay, but what kind of function is this? As you can see, this particle is undergoing oscillation. Okay, particle is undergoing oscillation along y-axis. Now in the chapter simple harmonic motion, we have already seen that oscillatory motions are always periodic. Oscillatory motions are always periodic. So that means this function, it must be a periodic function. So that means this function will be a sine function, cosine function, secant function or cos function. Okay. So let us take this function to be a sine function. Okay. So y is equal to some a sine something into x plus minus something into t plus minus phi. Okay. Now, why I have written like this? See, this instead of sine I can write cos, I can write cosec, I can write sec. Any periodic function will do, satisfy this condition. Okay. Now, this sine of this function, now this function can have a value of maximum value of plus 1 or a minimum value of minus 1. Now, if this function has a maximum value of plus 1, in that case y will be equal to plus a, this value. Okay. And in case the sine of this value has a value of minus 1, then in that case we will have y is equal to minus a. Okay. So that is the reason I have written like this. Now, what is the meaning of this box? Okay. Why I have written like this? See, function y is a function of x and t. That means y will be a function of x plus t. So both terms need to be there. And I have written phi because see, for this particular point x is equal to 0, t is equal to 0, and in this phase is also 0. But if the motion starts somewhere from this point or somewhere here, in that case initial phase will not be 0. So I have written this phi to be the initial phase. Now what about this box? What about this box? Okay, the box signifies that along with this x there must be some additional term, along with this t there must be some additional term. Now why is that? Why is that you need to have an additional term? Because this is a sine of some angle. So this is an angle. So if this is an angle, this term as a whole, it should be a dimensionless quantity. This term as a whole should also be a dimensionless quantity. Okay. So let us write with x, we'll write k. For time being, suppose we don't know what is k. Okay. We will find what is the value of k. Okay. Instead of k, I can write a, b, c also. Okay. So this is k times x, and this is some omega times t. Suppose omega is angular frequency, but suppose presently we don't know what is omega. Okay. So omega can be a, b, c, anything. Okay. So we have k times x, omega times t, but the only condition on k and omega is, see, I have written something with x, something preceding x. So that something quantity must be having a dimension of 1 by length, so that this quantity is dimensionless. Similarly, this quantity should have a dimension of 1 by t, so that this is dimensionless. Now phi is already an angle, it is a dimensionless quantity. Okay. So that is the only purpose of writing this k along with x and omega along with t. Okay. But still we don't know what is the value of k and omega, and in between kx we have written plus minus. Okay. So in a given wave, either it will be plus or it will be a minus. Okay. You can't have both plus and minus. There is a different meaning of having a positive sign, there is a different meaning of having a negative sign. What is that meaning? We will see later on. This similarly, this initial phase phi, it can have a positive value or it can have a negative value, but not together. Okay. Either so, you will have only in a general equation you will have only one sign, either plus or minus. Okay. So now we will see what is the meaning of k, what is the meaning of omega. Okay. So now suppose we have this equation y is equal to a sin kx plus omega t plus phi. Okay. Now first we will see what is k. What is k? Okay. So to understand the value of this k, let us make these two terms 0. So let us take time to be 0 and initial phase to be also be 0. So now these two quantities are 0. So we have y is equal to a sin kx. Okay. So now see, in a wave we say that distance between these 2 points, it is lambda. Okay. Distance between these 2 points is lambda. And what is the similarity between these 2 points? These 2 points, see, this is 0 and this is twice pi, isn't it? This is 0, this is pi, this is twice pi. That is, they are in the same phase. So wavelength is the minimum distance between 2 points which are in same phase. So now this y is equal to a sin kx. This is same as a sin kx plus twice pi n. Okay. So in kx, if kx is an angle, to this angle if I add 2 pi n, I will get the same value. Okay. So that means sin kx is equal to sin k, if I take k common, x plus twice pi n by k. Okay. So the phase is same. Okay. Now see, what is x? This is x axis. This is x axis, this is y axis. So x is the displacement along horizontal direction. Okay. So if I am adding to x, I am adding a certain quantity so that I am getting the same phase. Okay. And as I told you, wavelength is the minimum distance between 2 points which are in same phase. So for this minimum distance, this value of n should be equal to 1, not 0. If I take this n to be 0, you are at the same location. You are at the same location. So to get this next location, n should be equal to 1. So that means for n equal to 1, this is twice pi by k is equal to lambda. That means to a particular position, if you add a distance lambda, you will reach a point which is at the same phase as the previous point. So that means twice pi by k is equal to lambda, or k is equal to twice pi by lambda. So this is the value of k. This k is called angular wave number. Angular wave number, or simply wave number. Okay, so this is k. Now next we will find what is omega. So our next goal is to find the value of omega. What is omega? So now to find omega, we will make these two quantities 0. So we will take x is equal to 0 and phi equal to 0. So we have y is equal to a sin omega t. Okay. Now again, to get the same position, we have y is equal to a sin omega t plus twice pi n. If I add twice pi n to this value, I will get the same value, same displacement. Okay. So that means the phase sin omega t, this is sin omega t. So here if I take sin omega common, it is t plus twice pi n by omega. So to this time, I am adding a time so that I am again getting the same phase. So what is the minimum value of that time? That is the time period. Okay. After one time period, the wave will be again getting the same phase. So that means for minimum value of this is for n equal to 1, not n equal to 0. Otherwise, you will be at the same time, same location. Okay. So for n equal to 1, we have twice pi by omega. This quantity which is added to this time must be time period. So this is t, or omega is equal to twice pi by t. So this is omega. This is called angular frequency. Angular frequency. So now we know what is k, we know what is omega. So now let us see its other implications. So suppose we have two equations, y is equal to a sin kx minus omega t, and we have, or y is equal to a sin kx plus omega t. Okay. So now we will understand, like looking into equation, how to say whether the wave is propagating along positive x-axis or negative x-axis. Okay. So now see this kx minus omega t, this is the phase. Here the phase is kx plus omega t. Now for a given wave, the phase has to be a constant, okay, because the phase decides the form of a particular wave. Okay, like see, if I am drawing a wave like this, then I am assuming that this form continues. This form continues. Okay, just by looking at one particular form, we assume that the form of the wave continues. Now the form will continue only when this phase is a constant. Now in this term, see this, though this phase is a constant, but x and t as the position, as the wave propagates in this direction, the value of x keeps on changing, the value of t also keeps on changing. Now time, we know that it is a positive quantity, and as time progresses this quantity will become more negative because there is a minus sign. Okay, so this value is getting decreased as time is increasing, this value is getting decreased. Now to keep this constant, this x must increase in the positive direction. Okay, so that means if we are having an equation a sin kx minus omega t, this represents a wave which is propagating along positive x-axis. Okay, I am repeating once again. See, in this case time is always positive, so as time progresses, time is increasing, time will always increase, so this quantity will become more and more negative. So to keep this constant, x must increase in the positive direction. So this equation is representing a wave propagating along positive x-axis. Now whereas in this case, see omega t, it is positive omega t, so as time increases the omega t will keep on increasing. So now to keep this quantity constant, kx must decrease, so that is possible only when x will increase in the negative direction. So here x is negative. Okay, so this is a wave representing which is progressing in negative x-axis. So if you have kx plus omega t, it is a wave propagating along negative x-axis. If you have a wave representing as kx minus omega t, it is a wave progressing in positive x-axis. Okay, this is one fundamental concept. Okay, now there is one more way to analyze this. Like as I told you, this phase should remain a constant, okay, for a given wave. So here kx minus omega t is constant. Okay, and as we have previously already seen that kx minus omega t represent a wave traveling along positive x-axis, and kx plus omega t represent a wave propagating along negative x-axis. So this is kx plus omega t, here it is kx plus omega t is a constant. So this is k dx minus omega dt is equal to 0. K dx minus omega dt is equal to constant differential is 0. Dx by dt is equal to omega by k. Okay. Now see this wave, it is propagating along x-axis. This is x-axis. This is y-axis. Wave is going in this direction. So this dx by dt represents the wave velocity. So here the wave velocity v is equal to omega by k. Okay. For this is the wave propagating along positive x-axis. In this case, k dx plus omega dt is equal to 0. Okay. So here we will get dx by dt is equal to minus omega by k, or v is equal to minus omega by k. Here the velocity is negative. Okay. So this is negative velocity implies wave is propagating along negative x-axis. Positive velocity implies the wave is propagating along positive x-axis. Okay. So wave velocity is represented by the ratio omega by k. Okay. This omega by k represents velocity that can also be checked like this. Like see, omega, it is twice pi by t, and k is twice pi by lambda. So from this we have omega by k is equal to twice pi by t by twice pi by lambda. So this gives lambda by t. Lambda is the wavelength and t is the time period, and this ratio is the wave velocity, v, the wave velocity. Okay, so these are the few basic concepts. Now let us see few more things. So now for this equation of wave, so now this is kx minus omega t. Okay, so that means this is a wave propagating along positive x-axis. So that means this is a traveling wave. So this equation represents a traveling wave or a progressive wave. Traveling wave or progressive wave. Okay, so let us see in what other forms this equation can also be written as. Like I can write this as y is equal to a sine k is twice pi by lambda into x minus omega is twice pi by t into t. So if I take twice pi common, it is y is equal to a sine twice pi x by lambda minus t by t. Okay, so this is one way of writing this equation for wave. This is one way, this is another way. Now what is the advantage of writing like this? Suppose equation is given like y is equal to 2 sine twice pi x by 4 minus t by 3, and it is given that x and y are in centimeter and t in second. Okay, in that case, from this, looking into this equation, we can say that amplitude is 2 centimeter. This is lambda, so 4 centimeter is the wavelength, and time period is 3 seconds. Just by looking into the equation, by comparing the coefficients, we can identify the wavelength, amplitude, time period, frequency, and so on. Okay. Now this equation can also be written as, like, if I take lambda common, it will be y is equal to a sine twice pi by lambda. I'm taking lambda common, so this is x minus lambda by t into t. Okay, so now what is lambda by t? Lambda by t is velocity, so this is y is equal to a sine twice pi by lambda x minus v into t. So this is another way of writing this. Okay, so instead of lambda, if some numerical value is given, instead of this v, some numerical value is given, then just by looking into the equation, you can say this is the wave velocity, this is the wavelength. So these are the other forms of, standard forms of writing the wave equation. So this is the first video with respect to the wave chapter, and I hope this video is beneficial to you. Please do give your feedback, and I will post the other few videos very shortly. Okay, and my best wishes to you for your academic endeavor. Good luck.